Alright, there's the opto isolator circuit. Those are H11D1. There's a shadow on there. Here. See that? H11D1 opto isolators. And the way these work, if you're not familiar with them, is that they have LEDs on this side and phototransistors on that side. So when you turn the LED on with a signal in here, then the phototransistor turns on and it acts like a little optical switch, all fully self-contained. And what I've got is I've got it hooked up to the function generator in a crisscrossed manner, so that when the function generator, when this lead is positive, this one will be on and this one will be off, and when this lead is negative, this one will be off and this one will be on. So it's a flip-flop kind of thing, right? I've got the two LEDs there so that you can see what's going on, and then here's the 9-volt battery that powers the transistor side of the opto isolators. The LED side, of course, is just powered by the function generator itself. So and here's the oscilloscope, and that's going to be the function generator trace, and this will be the drain, MOSFET common drain trace. And I'm using 2 volts per division for the function generator trace and 50 volts per division for the drain trace. Okay, so first let's just go ahead and look at what how the opto isolator works. So I'll turn the channels on. Oh, and we're triggering off of the function generator through the external trigger input to the scope, so that we get good solid triggering and correct phase relationships. All right. So now I'm going to turn up the. Well, I've got the function generator set for all negative going pulses, but actually right now what I want to do is use a symmetrical square wave pulse. Okay, so now we're going back and forth around that 0 mark with no offset. Okay, so now when I go up with the drive like this to 5 volts or so, well, that's 2 or 3 volts. That's really all we need to drive the opto isolator. And I got one of them coming on. What's going on here? Take 2. There we go. I just had one of them. One of the LEDs was leaning over against its resistor and was shorted out, so it wasn't coming on. So when I go up with the drive, you can see both of the LEDs coming on nice and brightly, and that's because we're at really high frequency. So what I'll do is turn the frequency down so that you can see that the LEDs are flashing alternately there. Boom, 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 boom. And so that's the signal from the function generator is coming in here, turning on the optical signals on this side of the opto isolator, and then that is switching transistors inside the opto isolators to turn on the LEDs with this battery power supply here. So there's no electrical connection between the function generator and the LEDs. It's just optical in there, and there's a lot of standoff in there because they're not electrically connected at all. It's just connected through the light. Alright, now what I want to do is go back up to the faster oscillation rates that we've been using. Let's go to 200 hertz there, and and then I'm also going to go to the only negative going. And so what that means is that only one of the LEDs will be on, right? Just the one that's receiving the negative on the red lead makes it positive on the black lead, so that turns on that LED. All right, and now I've also got the TarBaby with the new load, which is 5 50 ohm 10 watt resistors in parallel. So that gives me a 10 ohm 50 ohm 50 watt resistors in there. So when I put them in parallel, that gives me a 10 ohm 250 watt handling load in the mineral oil. and so that's the load. The little wirewound resistors on ceramic tubes, very similar to the original Ainsley load. All right, now, okay, so now I've got the gate drive hooked up to the function generator, which is also still driving the opto isolators. But now, so now we're just back to where we were before. Opto isolators not being used, function generator driving the gates of the TarBaby. All right. So now what I want to do here is just make sure that the oscillations are still here, right? So let's hook up the battery. Hook up the battery. I'm getting good at doing this with one hand. Well, I thought I was. You try it. All right, battery's hooked up. That's battery voltage and current right now. And so now, and there's the battery voltage on the B trace, 36 volts. This is 50 volts per division, remember, so 36 volts. So now I'm going to turn up the amplitude of the drive again. And there's our oscillations, okay, so that still works. We got good oscillations in there on the gate and the thing, all right. So, but look at the current. The current's only 80 milliamps. Okay, if I really crank up the drive, I get up to 120 milliamps or so, something like that. So that's not going to heat the load dramatically, something, you know, and all that heat there is left over from my tuning adventures. Okay, so now let me turn the gate drive back down so that the drain goes off. Drain is off, and then we'll take the leads, the clip leads that are connected to the gate, and move them over to the output of the opto isolator. Okay, that's one, and that's another one right there. Okay, so now function generator is driving the opto isolators. Opto isolators, without even having the power connected together with the main circuit, is going to be pushing the gates through through this same little clip lead as before. Okay, so now when I turn the amplitude on, well, see how we immediately get nice, good MOSFET switching there from the battery voltage down to the zero baseline. So the MOSFET is switching fully. All right, and look, 1310 milliamps, 1.3 amps going through there, and I guarantee you that that is going to be heating up the load. Now, which MOSFET is heating now? Which MOSFET are we switching? For some strange reason, I still think that we're switching this MOSFET. I haven't made any mistakes in the wiring, but this is the one that seems to be getting warm right now. All right. So, and at one point earlier, I was able to get some oscillations in there by varying the... See, what I'm doing is I'm varying this signal, which is the signal to the input of the opto isolators. And the opto isolators are switching that 9-volt battery and the LEDs, and that's giving me the gate drive signal here. So it doesn't take much input, just 2 volts. There, negative 2 volts is enough to turn on the opto isolator, and that gives me the full MOSFET switch right there. Boom, it's fully on, and it's transferring current. And you know, I can go beyond that with the input, but it doesn't do anything else because the MOSFETs are already fully on. And again, I have not been able to reestablish the oscillations reliably. Sometimes I can get them in there, especially if I have really noisy switching. It's also interesting to go to other waveforms for the drive and see what happens. Sine wave, below the line, symmetrical sine wave. Okay. Now, there are, ooh, almost. Triangle wave drive. Alright. Now, here I have symmetrical drive. Focus. There. Now I found if I turn the offset, see this works even with the function generator, right? So if I turn the offset, you see how there the MOSFETs are completely off now because we're at battery voltage. And then here I have switching, and then when here I have MOSFETs are completely off. As I crank the offset down now, I get switching and good current flow. Oh, sorry, off, drain voltage high, current 0, coming down, switching in that range. And then I can also keep cranking that offset down, and boom, see how that line falls all the way to the 0 baseline? That means the MOSFET, at least one of them, is fully on, and look at the drain current. That load is heating up like a mother now, okay? And I don't really understand why this does this. Boom. Even through the Opto Isolator. At first I thought it was an effect of the function generator, but now I think I'm just, I don't know. One direction, the other direction. One direction, the other direction. One direction, the other direction. MOSFET's fully off, MOSFET's fully on, I think. Okay, so there's a range in there where they're completely off, they're switching, and then they're completely on, not switching, just on. I wish somebody would explain that to me. Alright, thanks a lot for watching. Look, I still have over 12 volts each on the batteries. Oh, and somewhere up here, oh yeah, here's that big capacitor that I bought today. Thing's a lot bigger than a Coke can. Thanks for watching.